Welcome back to another CommCon Virtual 2020 session. Today we have Phillip and Andriy from Sippy software. They're going to talk to you about building a bigger, badder back-to-back user agent. I'll catch you after their session. So over to you two. Thank you.
Thanks for joining everyone today for this session. Today's topic is building a bigger, badder B2BUA. This presentation will sort of document what Sippy software does and talk a little bit about our development process revolving around our redevelopment of the B2BUA component into GoLang. We'll take a quick look at some of the performance results and stuff like that as well. And we'll sort of also talk a bit about the choices that we made along the process. Initially, when we started developing the Python version of B2BUA, and some of the decisions that made us want to shift and rewrite the component in Go, followed by some performance testing towards the tail end. And then we'll wrap up and sort of give a look of what these changes sort of represent as part of production scale releases would look like. So just to start us off with, my name's Phillip. I'm the product manager at Sippy Software. I've been around for about 3 years with the company. And we also have today Andriy, who is our senior backend developer. And he's been very critical to the development of the GoLang B2BUA. Our company was founded by Max. He's also doing a presentation as part of the series. And he started Sippy Software in around 2006. And part of our corporate mandate is to sell soft switches out to Class 4 and Class 5 soft switches for wholesale and retail environments. We have 2 offices, one based in Vancouver, BC, and one based out of the Ukraine, and 20 staff in total. We also have a nonprofit sort of open source research and development team that focuses specifically on open source projects like Go B2BUA. And we've been active in the open source community since 1998. We've worked on a number of open source projects from RTP Proxy, RTP Cluster, NatHelper, and more specifically and relevant to this conversation, the B2BUA components. And much of this funding comes from tax credits that we get from the SHRED program in Canada. So for those that don't know what a B2BUA does or operates, the easiest way to explain it from a 40,000 foot view is that the B2BUA handles a lot of the call processing, trying to figure out where your calls are going between 2 user agents or 2 calling parties. So you might have Alice on one end and Bob on the other end. And as Alice dials out to Bob, there's a whole bunch of routing and billing and all sorts of different decision trees that need to go through in order for that call to get connected. And that's the central tenet to the B2BUA. It'll help facilitate both of the caller and callees and manage a lot of the business decisions in between. The call control logic sort of acts as an intermediary between user agents, and it passes the events from one end to the other and really makes a lot of the decisions that are needed to connect those calls. This gives the B2BUA the ability to manage the calls and all the data that gets passed between each end. And the most important part relevant for this particular discussion is that relates to the scalability of this component. For every phone call, there's a set number of operations that the B2BUA needs to go through, and that's for each individual call. And when you scale up the number of calls, or the number of calls that are going through the system at any point in time, it needs to be able to do that reliably and very quickly. And those were two of the main driving factors into getting us started and trying to look at how scalable the B2BUA component is and what we could do to improve that through the course of our development of this component. Here I'm going to turn it over to Andriy to talk a little bit about the programming decisions that were made as part of this redevelopment effort. Andriy?
Hello, my name is Andriy. I'm a backend developer for Sippy software. The Sippy project has started before 2006, so the choice of programming language was based on those present at the time on the market. The GoLang was first released in 2009, and it was not an option for us at the time. The goal was a language which is suitable for business development, but at the same time quick enough and reliable enough to do the voip processing. So, for example, we wanted to avoid core dumps, crashes of the application, which might be exploited from the security point of view, memory overflows and such. So the choice was made, and Python allowed us to achieve most of those goals, but it had several disadvantages, of course. Being a scripting language, Python runs around 10 times slower than the same C code, basically, which is not that bad for a scripting language. But the biggest disadvantage became clear a bit later when multi-core systems became a standard. These forced us to use an approach to overcome this disadvantage. So we needed to create to run a bunch of processes so we can utilize the power of the available hardware. Also, with time, business part of the project, business code, also grew bigger, which also showed a problem with Python as non-strictly typed language. The refactoring and such became much error-prone, and basically maintenance of the code became more difficult. So around 2013, we discovered GoLang, which basically had all those advantages we seeked from the very beginning. But in addition, it added a multi-threading, which allowed us to abandon the multiple processes approach, which allowed us to simplify the architecture of our system a lot. Also, being a strictly typed language, GoLang allows to make sure the code is quality code, even when we make big refactorings. So maintenance of code became very much easier. We started with rewriting parts of the B2BUA in GoLang, and this showed that the transformation of Python into GoLang is pretty much straightforward and easy. The GoLang has garbage collector, which makes basically memory management for a developer basically the same as in Python. Standard libraries of Python and GoLang are on par. Standard library of GoLang, of course, is quite modern. Missing libraries or some exotic ones can be easily included with brilliant feature of GoLang CGO extension, which allows to access C libraries directly from GoLang code. GoLang still slower than C, but only twice as much. But that means the GoLang 5 times faster than Python. Additional bonuses are better memory consumption and Go routines. In Python, memory management is a bit not very good because it uses for structures for class instances, for example, dictionaries, which means when you need to access a member variable of a class, you need to make a search on a dictionary. Dictionary also it's some additional space. With GoLang, it is basically the same as with C. You have old plain data structure, which is accessed directly, which makes it memory consumption smaller and access is faster. Also, there is a Go routine, a feature of GoLang, which basically, as I heard someone called it fibers. When you have OS threads, the Go routines allow you to use the threads not directly but indirectly. So you basically write the code as with usual threading, but GoLang multiplexes it on real operation system threads, which allows you to overcome the limitations of the operating system when it may have some limitations on number of processes to be run simultaneously on this hardware. And when you need much more of the things to run simultaneously. Basically, the GoLang was good enough. We started a bit later to rewrite our SIP stack too, and it was a good step. Basically, we received a code which runs almost 5 times faster and uses almost 2 times less memory. And also we removed a hurdle with multiplexing the call processing between CPUs. Philip?
Thanks, Andriy. So now we'll talk a little bit about some testing around Python versus GoLang. We'll give you some sort of head-to-head comparisons between our Python version and our GoLang version of B2BUA. Out of these tests, you'll sort of see an initial set of tests that sort of test the limits of where Python sort of end, all the way up to the high point of Python at its capacity. And then we'll get a chance to take a look at where things sort of fall over when we were looking at the GoLang version of B2BUA. And two of the things that we're really focused in on as part of this presentation is CPU utilization and the memory footprint when we're using both the GoLang and Python version. And then we'll, at the tail end of this, we'll also do sort of like more production scale level tests that are a little bit separate from this. And we'll see how that impacts things like call processing time. So in this small scale test, we're just really looking at signaling and how quickly the B2BUA will be able to respond to some of the SIP messaging that gets passed through. In this case, we're testing with a 4-core i7 with about 16 gigs of RAM. This gives you an idea of where things sort of sit to the sort of range at which Python can operate within. So we would see this red line here is the GoLang B2BUA, and the blue line here is the Python version. And on the x-axis, horizontal axis, we'll see calls per second and CPU utilization. So here, you could see that the Python version of B2BUA will cap out at about 45 calls per second. If it's going over the 100% mark, there's some spillover onto a second processor out of this 4-core system. So that's why the numbers are a little bit higher here. But when you're looking at this, you can see a big difference between how many calls per second and the CPU utilization is here. You're getting a fair bit of extra CPU power available to you when you are using the GoLang B2BUA. And this is to this extent, this is where the Python version would fall over, and we'd be reaching our capacity on the Python version. So we still have a lot of overhead room available to us using the GoLang version. So this is the next graph here is the same graph, but sort of stretched out to give us a better indication as to how many more calls that we can process for that same processor. Here, the GoLang version of B2BUA will cap out at about 250 calls per second on the single processor versus the 50 that you would get out of the Python version. That's quite a bit of savings in terms of processing power available to a given system. So I think these sort of really do reflect the difference in CPU utilization here. For memory utilization, it's a similar story. Andriy's tests that he ran earlier, they do have, the system does have a lot more system memory allocated to it, so it's not so much the bottleneck, but there is still a substantial number of memory savings here between the GoLang B2BUA and the Python version. It's still about double here. And this is what the memory utilization would look like, when we're pressing the GoLang version as far as we can. So it's still using about 500 or half a gig worth of memory for the one processor processing a few calls. So this is what it would look like in a sort of a production level setting. In production, you might not have a box that's set up strictly for call processing. You'd have other things running in tandem, like an invoicing system or health monitoring systems or writing and collection of CDR data. So this is more representative of what the same types of tests would look like in a production setting where you have other systems and processes running in the background. But again, we might see things capped out at about just under 200 or 150, where the CPU utilization is starting to get to a point where we're starting to see peaks of 100% CPU utilization. So when it comes to our licensing, we would never sell one of our commercially available software platforms beyond this point. But when we're talking about the GoLang version of B2BUA, we still have lots of threshold and available resources for us to go beyond just the 150, 200 calls per second range that are available to us currently in our commercial versions. So this gives you a bit of an idea of what this production system would look like. It's a 20-core CPU, 64 gigs worth of real memory. This particular hardware would cost a customer about $300 a month to rent this hardware, and we would typically give this out to a customer that would be running about 150 calls per second or about 8,000 concurrent calls. But with the added benefits of the GoLang B2BUA, we could easily push this upwards to 500, 600, as shown. So this is what it looks like to the extent of where this one. No, this one. This graph is will show how far GoLang could possibly take us. This graph here will show that the CPU utilization for GoLang will easily get us up to about 600, 750 for full CPU utilization. And this is more of a production level test given the hardware that we've shown. Sorry, these got a little out of order. And then the other thing that I wanted to demonstrate as part of this is with all the CPU optimizations and all the memory utilizations, the sort of end result that we can bring with this GoLang B2BUA is really highlighted by how quickly each of these calls can get connected. So our blue line here is the Python B2BUA, and the red line, which is almost runs parallel pretty much to the x-axis, y-axis. The call processing times are just fractions of what they take for the Python version. This is about 30 times faster. So if you could complete that, or initiate that call in 30% or 30 times faster, then you could complete a larger number of calls in that same amount of time, which really drives the performance benefit out of the same hardware that you would be able to get. So to sort of wrap things up here, we still want to let it be known that the Python version is still very stable. It still runs very well. And if your call capacity doesn't exceed like 150 calls per second, it's still a very viable choice to have. We do still continue on planning to support and make updates to the Python version of B2BUA for the foreseeable future. Certainly GoLang will be able to accommodate both those smaller customers as well as larger companies that need to process a greater deal greater amount of traffic. And the nice thing is the whole SIP messaging process is really fully covered by GoLang. And it does make a big difference when you're thinking about call volumes and how many minutes you could put through, or the number of calls the switch will be able to process through. I also think that our work in the GoLang B2BUA also sort of points to the idea that there might be hard, fast limitations to hardware, and there's always still some rooms to optimize things on the software side. These tests are done sort of with the Python version and the GoLang version all on the same hardware. So just the change in the one component could cause some dramatic improvements into what you as a switch owner can actually expect to do, and that if you could increase your capacity without having to fork over a lot of money for new hardware, and going through the ordeal of changing out that hardware, migrations and whatnot, it sort of prolongs the life of the hardware that you have existing. And these changes really do facilitate opportunities to sell more minutes or sell more calls out to those customers without having to break the bank for hardware. So you could stretch out that hardware a little bit longer. So that pretty much wraps up our presentation.
Great, thank you very much. That was really, really interesting. Like I know Sippy software from RTP proxy, but I've never really kind of delved into much more than that. And kind of seeing real life stats on, we used to have this Python, well, you still got this Python thing, and here's a GoLang equivalent, and look at the huge improvement. GoLang's been around for enough years now, and more and more, I'm seeing more and more within the VoIP space kind of move to GoLang. As a Node.js developer, I still love Node, but GoLang really has its place in these types of applications. And yeah, especially with kind of trying to get more legs out of older hardware, or just making it easier to deploy it into a virtual environment. That's really, really cool. So we're going to head over to the Riot room, Riot/Matrix room, for Q&A. So that's at riot.commcon.xyz. And there we'll be able to chat with Phillip and Andriy. And we'll probably, we'll move over to a Jitsi room to have live video Q&A as well. And that will be orchestrated over on Riot. So go join the Riot community, riot.commcon.xyz. All the links will be in the description below. All I've got left to say is thank you very much for joining us, both of you. And we'll see you in a minute live. Thanks. Don't go anywhere quite yet, though. We've got to say thank you to all of our sponsors. Without them, none of this would have even happened in the first place. So for our platinum sponsors, we've got Toulouse, Voxbone, and Ciara. For our gold sponsors, we've got the Matrix Foundation, Vonage, Sangoma, Telviva, and Loway. Our silver sponsors are Aptosay, Pion, Telco Bridges with ProSVC, Avoxy, 8x8 with Jitsi, and FirstCom Europe. Then we've also got community sponsors, QXIP and Cycol Systems. Without any of them, this would never have even happened. You wouldn't have had all of this free content on YouTube. So go say thank you to all of them. Go look at what they provide, what services they offer, and have a conversation with them all over on Riot, riot.commcon.xyz. The link will be in the description below, along with links to all of our sponsors. You can go and watch preview videos from all of our gold sponsors right now over on YouTube. The links will be somewhere over here. all I've got to say is thank you to all of our sponsors, and I'll see you over on the Q&A shortly. Cheers.